So this is the open response part of the video. Test A, starting with number 10. It says factor the following expressions if possible. If not factorable, please write prime. So this is on version A. If you're thinking that this is a perfect square quadratic binomial, you are correct that they're perfect square terms, but it's not a perfect square quadratic binomial because this plus sign messes it up. Okay? The only way you could actually factor a perfect square quadratic binomial is if you had a minus sign right there. Because after all, in order for you to end up with 2 terms instead of 3, those middle terms have to cancel out. And there is no way the middle terms will cancel out if you have a plus. So this is technically prime. I hope this makes sense. Let me do a couple of review questions. If I said x squared minus 9, could you factor x squared minus 9? Yeah, because positive 3 times negative 3, that'll give you a negative 9. And if you do distribute, the middle terms will cancel out. Check it out. X times x, x squared. X times negative 3 is negative 3x. Positive 3 times x is positive 3x. Positive 3 times negative 3 is negative 9. And notice that the middle terms do cancel out. Now that would not have happened if this was a plus sign. Kind of like up here. It's a plus sign. So when it's a plus sign, you cannot factor it. You need a minus sign in order for the middle terms to cancel out, in order for you to end up with a binomial. So right off the bat, even if you have perfect square terms, if that middle sign's a plus, it's not factorable. That's why we say prime. Let's move on, number 11. What should I always try to do first? Pull out the GCF, right? Now, what is the GCF right there? What could I pull out from all 3 terms? What could I pull out from all 3 terms? 2? If I do pull out a 2, what would be left? 25x squared minus 30x plus 9. Now, some people got this right. However, you need to keep going. You need to look at the inside of the parentheses, what's in blue right here, and recognize that in there we do have a perfect square quadratic trinomial. So you're supposed to attempt to take the square roots of those guys and plug them into your answer format and see if it actually works. So the square root of 25x squared is 5x. The square root of 9 is 3. So you have a 5x and a 3. Now the question is, if I need, at the very end, when I distribute and I say 3 times 3, I need it to be a positive 9. But when I combine the middle terms, I need it to be a negative 30. So instead of positive 3 times positive 3, we're going to go with a negative 3 times negative 3. That'll give me a positive 9. And when I combine them in the middle, it will give me a negative 30. So you're supposed to actually check. So if you did go 5x times 5x, you get 25x squared. If you go 5x times negative 3, you get negative 15x. If you go negative 3 times 5x, that's another negative 15x. And if you go negative 3 times negative 3, that's positive 9. So notice that the middle terms really do end up giving you this negative 30x. So don't forget about the 2 out. Let's bring it down to the front. So the 2 out here in the front, and that other factor form is a completely factored form of number 11. Number 12, the a value is 1, so we could set up this, and all we need to do is think what times what is negative 56, that if I combine together is negative 1. Make a list if you're confused, but what's the answer there? What times what is negative 56, that if you add together is negative 1? Negative 8 times positive 7. That's right. That'll give you negative 56. If you combine them together, it does give you a negative 1, the b value in the middle. Let's move on to number 13 right here. There's 4 terms. There's x's and y's, so obviously grouping is probably the best method. Let's start by separating them. So again, step 1 was to separate the 2 groups. I see a lot of students do this, like put some parentheses. Don't do that. That throws me off, and I know it messes some other students up. So don't use parentheses. Actually make some space between the first 2 terms and the second 2 terms. Put some space between there. And then on factoring by grouping, you look at your first group and you ask what could you pull out. And there is a 5 and an x in common in both terms. And when you pull out a 5x, you end up with the 4x minus 3. And in the second group, we could pull out a y for sure, and also a 4, but it's even better to pull out a negative 4y. If I do pull out a negative 4y, I will end up with the exact binomial 4x minus 3. If I wouldn't have pulled out a negative 4, you'd end up with opposite signs. So it's very important that you pull out a negative 4. That way you end up with the same sign binomial. You end up with the same 4x minus 3 and 4x minus 3. Now once you have that same exact binomial, let's factor it out of both groups and put it out here in the front. And if we do pull out that binomial, that means that the 5x is the only thing left, and also the minus 4y. So both of these would be left over down here in this parenthesis. So 5x and minus 4y. 5x from here, minus 4y from there. And that is your answer for number 13 on version A. Let's move on. Number 14 on version A. We should recognize that we have a perfect square in the front and a perfect square in the back. So it'd be a good idea to try to factor by taking the square roots of those and applying them to the shortcut, plugging them into your answer format. So the square root of 4y squared is 2y. So you put 2y there and 2y there. And then you say the square root of 25 is 5, so you put a 5 here and a 5 there. Now you have to think about the signs that belong here based on the fact that your c value is a positive 25. So it's either going to be positive 5 times positive 5 to give you a positive 25, or a negative 5 times a negative 5. That'll also give you a positive 25. And of course, your middle value is negative, which means that you need both of those to be negative. So that's your factored form on number 14. Now, you could also write it as one single binomial squared. It's totally up to you. I'll accept this or this, whatever you want. Of course, it's important to check your answer to see that it actually works. I recommend, if you have some time left over, to go back to your answers and actually check it. 2y times 2y is 4y squared. 2y times negative 5 is negative 10y. And then negative 5 times 2y is negative 10y. And if you combine those together, it does give you the negative 20y, etc., etc. Let's move on. Number 15, we do not have perfect square terms here, so we can't do the square root shortcut. But we do have an a value of 8, which means that we have to go through that pretty long process. Step 1, multiplying a times c. We end up with negative 24. Then we need to think of the multiples. Step 2 is think of the multiples of negative 24, like 1 times 24, like negative 2 times 12, like negative 3 times 8, negative 4 times 6. And of course, we're thinking of the multiples of negative 24 that combine together to give us the middle value, positive 10. So if I add negative 1 and 24, I'll get 23. That is not 23, that's 10, so that didn't work. If I add these together, do I get 10? No. Yes. Yes, positive 10, and that's exactly what we want. So we know that this is the correct pair of numbers that we want. We don't have to do any sign change. That's the correct pair of numbers we want. So step 3 is jumping to our answer format that's going to be in factored form. And I hope you guys remember that what belongs on the first part of your binomial, and the first part of your binomial is ax without the square. So you're going to actually type in or write in that 8x without the square. And of course, we write that on both, 8x, 8x. And now we take this pair of numbers, the negative 2 and the positive 12, let's put them right there in those blank spots. So let's write in the negative 2 and the positive 12. Now that looks like it's in factored form, but the problem is if you check it, 8x times 8x is not 8x squared, it's 64x squared. So that's why it's so important to remember step 4, which is reducing. Now this step is supposed to be done in your head, but I recommend to actually just do a little division sign and divide by 2. Divide by 2. So you end up with 4x minus 1. And over here we could divide by 4. So we end up with 2x plus 3. So that's your factored form right there. Now the second part of the backside of the test is solving equations, and we have to remember to use zero product property. It's really easy whenever you have something times something equal to 0, the first something could be 0, the second something could be 0. So just split them and set them each equal to 0. Once you split them, solve them. So minus 12, you will get 3x equals negative 12. Final step would be to divide by 3, divide by 3. So x equals negative 4, and that is one answer. The other answer, add 1, you will have 3x equals 1. Final step is to divide by 3, divide by 3. So x equals 1/3 is the other answer. Let's move on to number 17. Now number 17, it is an equation. You do want to use the zero product property, but in order to do that, you need to first have it set equal to 0. So let's subtract 7x. And subtract 7x, which you can't really subtract 7x from 6x squared or from the number 2, which is why we're going to rewrite it. 6x squared minus 7x plus 2 equals 0. Now we have an equation equal to 0, and in order for us to use the zero product property, we need to first obtain multiplication. Something times something equals 0. And obviously this doesn't say that. You have something minus something plus something equals 0. So we want a factor to be able to get that multiplication. Now the problem is that our a value is 6, b value is negative 7, c value is 2. C value is 2. And we need to do that long process. Step 1, multiply a times c. That is 12. Step 2, think of the multiples of 12 that combine together to give you negative 7. So you could get 12 by doing 1 times 12, 2 times 6, and 3 times 4. That is an ugly 4. Anyhow, which pair of numbers combines together to give us the b value, which is negative 7? That would be the 3 and the 4, but that gives you a positive 7, and we want a negative 7, so you'd have to change the signs. So moving on to step 3. Step 3 is to jump to your factored form answer format. And once again, we take the ax, not the square. So that would be a 6x that we take. So 6x, you place that right here. 6x, you place that right there. And in the blank spots right here, we plug in the two numbers from step 2, the negative 3 and the negative 4, put them right there. Negative 3, negative 4. And then we divide by the greatest possible factor on each of the binomials. This is step 4. So if you divide 6 by 3 and the 3 by 3, you'll get a simplified binomial of 2x minus 1. And the other one, let's divide by 2, and you'll end up with 3x minus 2. Now, this is the factored form. However, this is still an equation. Some people just wrote that on their answer, and that's not the answer. That's just the factored form, and we still have the equals 0. So what I need to do is take that equals 0 and put it down in front right here, equals 0. So now we have an equation in factored form equal to 0, which means we could apply the zero product property, put 2x minus 1, set that equal to 0, take the 3x minus 2 and set that equal to 0. Now we could solve both of these to get our two answers. So if you add 1, we'll get 2x equals 1. Final step would be to divide by 2. So x equals 1/2. That is one answer. On the other one, let's add 2. We end up with 3x equals 2. Final step would be to divide by 3. So x equals 2/3. Those are your two answers for that one question. That was number 17. Jumping to number 18. Once again, it's not equal to 0. It is an equation. Let's get everything to one side to set it equal to 0. So I'm going to subtract 20 and also subtract 18x. So, of course, this will cancel and this will cancel. But what you do to one side, you must do to the other side. So let me subtract 18x also from the left side, and let me subtract 20 also from the left side to maintain the balance. So I have a new quadratic trinomial equation, 2x squared minus 18x minus 20 equals 0. Now some people might get scared here thinking, oh, I have an a value of 2. That means I have to use that long process. But that's not the case. What you're supposed to do anytime you could pull out a GCF is pull out that GCF. So let's pull out the GCF of 2, and we will have x squared minus 9x minus 10 left over on the inside. Now, of course, we still have the equal 0 out here. So if you want, you could divide by 2 to get rid of that outside 2 because it's an equation. You could do whatever you want as long as what you do to one side you do to the other side. So we'll still have the quadratic trinomial equation x squared minus 9x minus 10 equals 0. And now that the a value is 1, it's really easy to factor, split, and solve. So the question becomes, what times what is the c value, negative 10, that if I combine together gives me a negative 9? 1 times negative 10 is correct. So we're going to put a plus 1 times negative 10. And then after that, all we do is split it and solve. So we will have a x plus 1 equals 0 and an x minus 10 equals 0, which means that your two answers are x equals negative 1 and x equals positive 10. Those are your two answers for that one question on number 18. Now, number 19, we did not require you to factor, but we did require you to know how to use a square root, right? Whenever there's one x, let's get that x by itself. And how do we get rid of things? By doing the opposite. And the opposite of a square is a square root. But if we compare 19 to number 20, that also only has one x, which means we also get the x by itself. How do you get rid of things? By doing the opposite. And what you do to one side, you do to the other. But if you compare those two to the ones above, like right there, you're not going to try to get x by itself because you actually have two x's, right? You have x squared and you have an x, so you can't get x by itself because those are two different types of x's. But right here on 19 and 20, you could get x by itself because you only see one x. So to get rid of something, you do the opposite. And the opposite of a square is a square root. So when you take the square root of x minus 6 squared, that becomes x minus 6. And what you do to one side, you must do to the other. So you'll end up with equals. Now, when you do apply a square root, you have to put a plus minus in front of your answer. So it would be a plus minus 4. Now, after this, you need to still get x by itself. So you would have to add 6 and add 6. Now, you can't really add 6 yet to the plus or minus 4. You actually have to rewrite it. 6 plus or minus 4. And now you could actually do both situations. The 6 plus 4, which gives you 10. And also the 6 minus 4, which gets you 2. So those are your two answers, 10 and 2. So x equals 10, x equals 2. Last question on version A. For version B, I'll do a different video. So number 20, we want to get x by itself. So of course we don't want this multiplication of 64. You do the opposite, divide by 64, that'll cancel out. What you do to one side, you do to the other side. 9 divided by 64 cannot be done, and it can't even be reduced. So let me rewrite what I have. X squared equals 9 over 64. Now to get rid of the square on the x, I would have to apply the opposite of a square, which is a square root. And what I do to one side, I do to the other side. So I will have x all by itself. However, I do need to put a plus or minus right in front of my answer. When I apply a square root, I have to put a plus or minus in front of my answer. And when I do have the square root of a fraction, you end up splitting that square root to the top and to the bottom, which you end up with the answer 3 and 8. The square root of 9 is 3, the square root of 64 is 8. So my final answer is x equals plus or minus 3 over 8. And that's it. If you had version B, then this video really didn't help you. But I will make another video version B.